Okay, good day everyone. We are now on the second part of summarizing and organizing data. Previously, in our previous discussion, we know how to summarize and organize data based or using tabular methods. Today, we will be discussing about the different graphical methods in summarizing and organizing data. This includes frequency distribution or the frequency histogram, the frequency polygon, the ogive, the pie chart, and some other uh, notable graphical or graphs no, or graphical methods. Okay, let's start with the frequency histogram. This is an example of a frequency histogram. Now, as you can see here, uh, you have these boxes which have different heights. Now, you have the axis. Now, this is the horizontal or the x-axis, and this is the vertical or the y-axis. Take note of these. What are these numbers here? What are these numbers here? And how do you make these boxes? Now, there are some steps that we need to follow. So we have here the following. If you would recall your frequency distribution table, no, you have there class marks and class boundaries. Now we will be using those parts, and also most importantly the frequency, the respective frequencies. So we still need to make the frequency distribution table for us to create a frequency histogram. The first step, when you are done with your frequency distribution table, the first step would be to plot the class marks against the frequencies. So that is, in the x-axis your class marks, and in the y-axis is your or are your frequencies. Then after, the center of or the base, no, the center of the base of the rectangle or the midpoint of the rectangle should be your class marks, and the sides of each rectangle are your class boundaries. Now, if you would go back to this figure here, you have here your ages are actually your class marks. Now, this 20, 25, 30 are your class marks, and these are your frequencies. Then the center of each rectangle is your class mark, and the sides are your boundaries. So again, uh, the sides, no, you draw the sides, which are your boundaries. The class mark is the center or the midpoint, and the height of your rectangle is the respective frequency of that class interval. So that is how we create a frequency histogram. Now there are different shapes of histogram. You have unimodal, bimodal, and multimodal frequency histogram. Now the modal here denotes or refers to the peaks, no, the peak of a histogram. So for unimodal histogram, frequency histogram, we only have one peak. Now it can be called symmetric, skewed, no, symmetric or skewed. When we say skewed, skewed to the left or skewed to the right. Now symmetric histogram is that when we divide it into two, the left side has almost or equal shape with the left side. Now if we will divide this one, oh sorry. So again, if we divide uh, this histogram here, so they would be almost symmetric. Now skewed histogram are unsymmetric histogram. So it's uh, it might be skewed to the left or skewed to the right. So skewed to the left are also referred as negatively skewed unimodal frequency histogram. Skewed to the right are positively skewed unimodal frequency histogram. So as you can see here, if you divide them into two, so they are not symmetric. Now for symmetric unimodal, if you exactly divide it into two, they are almost the same. We will discuss more of these, or especially when we go or proceed to the third method. We will be calculating the skewness of a distribution of our data. We also have bimodal histogram, which means there are two peaks of our histogram. Now, if you will create a curve here, you have two peaks. While multimodal have multiple peaks, no, three or more um, peaks. A special type, which is a uniform frequency histogram. Now, I think we don't need to study uniform data, no, since the behavior is constant, so there's no need to analyze this type of data. So again, these are the three shapes of a frequency histogram. Now we also have another one, a frequency polygon. So this is an example of the frequency polygon. So same with the frequency histogram, the x-axis refers to the values, but the difference is that these are not class marks. No, these are actually the upper class boundaries. Sorry, rather these are the same with the class marks. However, the difference is that we will be taking getting the class mark of the previous frequency and the class mark of the next uh, frequency. When I say previous and next, so these are actually based on your data here. Now, if these are your graphs, if these are your data, so we will get the class mark before this, which is this one, and we will also be getting the class mark after this box here, which is this one. So as you can see here, we can create a frequency polygon directly. Now, if we have already the frequency histogram, then it would be easier for us to create the frequency polygon. And same with, again, for correction, same with the frequency histogram, we have to plot the class marks against the frequencies. So you will just have to get the midpoint at the peaks of each rectangle. Then get the midpoint of the previous, based on the previous uh, class mark, get the class mark, the next class mark of this rectangle. Then create lines. No, you connect the dots using lines. Then a closed shape, no, a closed shape figure is called your frequency polygon. So if we will go back to our example, so suppose we have a class mark at this point. We'll just assume the class mark here is 15. Since we only have a small space here, so we'll just assume that 15 is located here, and the next class mark is 65. So to create a frequency polygon, get the midpoint and connect here, and the midpoint again, then connect, then connect, and connect. So once you have connected all the midpoints or the class marks of your distribution, then you will have your frequency polygon. So that is how we create a frequency polygon. The next one are ogives. Now we have two types of ogive, the greater than and the less than ogive. So what's the difference? The less than ogive, uh, in order to create the less than ogive, we have to refer it to our less than cumulative frequency. Now, if you would recall, we have a less than cumulative frequency. Then the greater than ogive or the more than ogive is taken from the uh, greater than cumulative frequency. By the way, in addition, you have to make sure that the ogive is extended to the x-axis, where y is equal to 0. And also for this one. Now, we will have to extend it here. Okay, so we'll have to go to the point where y is equal to 0. So again, these are your less than ogive. The less than ogive is increasing. Now, if you would check your frequency distribution table or the cumulative frequency distribution table, the less than cumulative frequency is increasing while the greater than cumulative frequency is decreasing. Now, one good usage of getting the less than of using less than and greater than ogives is we can directly determine the median. So we will define this median. We will have examples this median on the next group of methods. Now, to give you an idea, median is the middle value of your data. So say for example, we have this frequency distribution, specifically cumulative frequency distribution table. You have the class intervals, class boundaries, the frequency, the less than frequency, and the greater than frequency. So which data, or the question would be, in creating your ogive, what are these values? Are these still the median, or the midpoint, or the class intervals? Now, are these the class intervals or class marks rather? The answer is no. Now, preferably, we will have to use the upper class boundaries of our frequency distribution. Now, the upper class boundaries are plotted against your cumulative frequency. So this will be our x-axis. Now, if you will be creating a less than cumulative frequency, this will be your y-axis. If you are creating a greater than cumulative frequency, this is our y-axis. So again, the upper class boundaries are plotted against the cumulative frequencies. Some would use class marks, but it is recommended again to use the upper class boundaries. So this is the equivalent graph of our example. Now you have your upper class boundaries plotted against the less than cumulative frequency. Then you have this graph here. Now it should look like an S, no, almost an S figure. Then this one is the greater than cumulative frequency is like an inverted S. Now take note of these values. If you would check your class boundaries, now this is the lowest class boundary, or which means, oh, which can only also mean as the upper class boundary of the previous interval. No, we will go back, no, step backward, move backward. So we'll get the 13.5 as the upper class boundary of the previous class interval. Then you have next is 62.5. Now that is the upper class boundary. When we move forward, now you have here 62.5. So that's how we create the ogives. Others would call it ogive, but we'll be pronouncing it as ogive. After ogive, we have pie chart. So this is an example of a pie chart. It can be presented in a simpler manner, or if you would like that, or if you would like to give some effects, you can use this type here. But how do we create a pie chart? It's simple. No. First is we have to draw a circle. That mean that means it represents the entire data, your entire data. So the complete circle means 100%. Then for each category, you calculate the slice size. Now, uh, and how do we get the slice size? Meaning, when I say slice size, kanisha, how do we get this size here? If you would ask, how would we get this one? Now, if we would be using percentage only, how can we divide our circle in? How can we get 6% of the circle, 18% of the circle? So we will make use of the slice size. Now we will convert it into degrees. So you will be using your protractors. Now since your protractors have degree measurements, so we can then get the equivalent degrees of your size. Say for example, if this is 6%, so you will get 6% of 360 degrees, and you measure that one, no, an angle equivalent to 6%, then that would be your slice size. And the formula is 360 times the category relative frequency. So if you have 360 times 0.06, no, for 6%, then you will get the equivalent angular measurement. Then you can draw now the slice of appropriate size for each category. So again, you use your protractor. I hope you already know how to use your protractor in measuring angles. We have a special type of pie chart which is called segmented bar chart. No? Example, you have this one. Now, if you have a data, commonly a segmented bar chart is used to represent a very few or a small value in your pie chart. But just for demonstration purpose, this is how a segmented bar chart look like. No, you have, among others, you have 6% are graduate students and 62% are college students, which comprises to 68%. Now, others would use, again, if you have a very small value here, but this very small value is composed of a lot of data, so you will be using a segmented bar chart to uh, represent or to present a small portion here. Now, let's proceed now to the other types of graphical methods. We have box plots. These are example of box plots. Now, we will be making this one when we discuss numerical methods. Uh, you have your box plots. Why? Because there are computations needed. Now, we need to know the mean, the median, the first quartile, the third quartile, the lowest observation, the maximum observation, and some upper fence, which is beyond the maximum observation. We also have time sequence plots. Now, this is a data which is measured based on, or which are based on time, plotted against time. So these are the data with respect to time. You also have probability plots. Now you have probability of a value, an expected normal value. Then you have your observed values. Another are scatter plot diagrams. Now, this is an example of a scatter plot diagram, and you can create a approximation a line. No, this is called the best fit line, which will be used to describe your data here, your scatter plot. Approximate, no, to approximate your scatter plot, and you have dot plots. You also have bar charts and stem plots. Frequency of your data. So you may be asking why, and you will be the one to answer that. Okay. So again, that would be your task, because in the next later on in the next slides, we will have you will be having an activity, you know, regarding comparative bar chart. So let's have this example. The ages of 40 students in a 60-point test are the following. You have here the different data here. Then our task is to make histogram, frequency polygon, a less than and greater than ogive. Okay, now again, the first step is we will be creating um, distribution table, frequency distribution for this. So that will be your task. Now you know already how to make the frequency distribution table. In the next slides, I will be showing you the answers. Okay, I'll be showing you the answers to these to these activities. So you will have to solve this on your own and check if you will have the same answers. So you have here your histogram. So these are the ages of students. So now these are the ages of 40 students who are taking a 60-point test. This one, so meaning there is a certain test the student took, which is 60 points worth. No, but actually the data are the ages of the students. So these are the ages of your student, and these are the frequency of your student. Again, kani, this, this one, this one, this, and these are your class marks. Now these are your class marks. This is your frequency, the frequency equivalent to this uh, class interval, and the frequency. These are the respective frequencies. This area here no, is your lowest class boundary. No, this is your class boundary. This is the upper class boundary no, of the interval. Okay, then the next is the lower class boundary of this interval, the second interval. And this is the upper class boundary of this interval. That is the frequency histogram. Next is the frequency polygon. Now, if you have to connect again this one, these two last points here, the first and the last points, you will have your frequency is polygon. How do we create this one? If you would observe, I have already here the class marks now of the previous class mark of 23.5 and the next class mark to 53.5. Then we'll have to connect their midpoints or class marks. Just connecting the dots. Use ruler. Uh, Here I can't use a ruler, so I will be just using freehand. But for your case, you have to use a ruler. Okay, you will now have a frequency polygon, and this is how it looks like. Next are the ogives. Now you should have these ogives. Now again, these are your upper class boundaries. It is recommended that we will use the upper class boundaries to make the ogives. Okay, here's a challenge. This, as what I have said earlier, you will have a challenge, no, to use or construct a comparative bar chart. Now, you will be answering this one in the modules. No? Just check your modules in Canvas. Now, where will you be submitting your answer for the challenge? You have a data below for smokers. Now, here's a research on how smokers and non-smokers perceive the risk of smoking. Construct a comparative bar chart for these data. So you have here the different perceived risks of smoking, very harmful, somewhat harmful, not too harmful, not at all harmful. Now, the different types have their own perception. Now, for smokers, they perceive smoking as very harmful. So there are a lot of smokers who perceive smoking as very harmful, but they still smoke. Oh, you have these data here. Again, this is your challenge. No, this will be in the enriched portion. By the way, the previous slides, this one, you actually have to submit these, your answers to these, in the enrich or engage part. Now, again, your answers to this activity shall be submitted in the engage. Again, submit it in the engage part, while the challenge will be submitted in the enrich part of our module. And submit them in the enrich part. Anyways, I will putting in the engage part as activity, no, as the title. Then I will put in the enrich part a title challenge. Okay, so that will be all for the different methods of summarizing and organizing data using graphs, no, or graphical methods. So stay tuned for the next one. No, the next lesson will be about numerical methods. So I hope you would study in advance those, because that they are also as important as the previous methods. So that will be all for today. Thank you for watching. If you have questions, you will have, or you can ask them later in our discussion board or during our TOA. Thank you and